Bismillahirrahmanirrahim. Assalamualaikum, students and physics enthusiasts. Here's another application of the law of conservation of linear momentum for a two-body system that undergo two-dimensional elastic collision. So just stick around till the end of this video. Watch and learn. This is the problem. A particle A moving 2.0 meters per second in the positive x direction collides with particle B moving 2.5 meters per second in the positive y direction. Assuming both have the same mass, find the speed and the angle of deflection of particle B. If particle A was deflected at an angle of 30 degrees above the negative x direction with a speed of 3.0 meters per second. The two particles, A and B, have the same mass, which is represented by small letter m. And as illustrated in the two figures, before the collision, particle A is moving at a speed of 2.0 meters per second. And it is heading towards the positive x direction, while particle B is moving at a speed of 2.5 meters per second, and its direction is towards the positive y axis. And just after the collision, we are given the information that particle A has now a speed denoted by v of A prime equal to 3.0 meters per second. And it is directed at an angle 30 point degrees above the negative x axis, while particle B is deflected with an unknown speed denoted by v of B prime, and the angle that it forms with the positive x direction is also denoted here by theta. So our two target variables are the magnitude of the velocity of particle B just after the collision and the angle of deflection with respect to the positive x axis. We are assuming that in this problem, an elastic collision happened, meaning that the two particles do separate after their collision. However, it is not safe to say if it is a perfectly elastic collision, in which case both the laws of linear momentum and kinetic energy conservations must apply. So, we are assuming that the system is considered an isolated system where the law of linear momentum conservation applies. That is, the total momentum of the system before the collision equals the total momentum of the system after their collision. So first, we have to apply this law in determining or in describing uh, the momenta of the two particles before and after the collision uh, for the x component, right? Remember that the situation concerns a two-dimensional uh, motion of the two particles. So we set up this equation. mvx sub a plus 0 equals mvx a prime plus mvx b prime, right? The product of the mass of particle A and its initial velocity along the x-axis is what is represented by this first term. That of particle B is considered zero, the fact that it is only moving along the y-axis. So it has no x component for its initial momentum. On the right side of the equation, all right, we have mv x a prime. This represents the momentum of particle A just after the collision. And the last term, mvx b prime, represents the momentum of particle B just after the collision. So, substituting our given quantities, uh, the mass of the two particles are the same. So in our equation here, all right, small m, which represents each of their masses, cancels out. So we are only left with uh, 2.0 meters per second, right? This is the speed of particle A before the collision. And that's equated to 3.0 meters per second times cosine of the angle, okay, corresponding to 30 degrees or 30 degrees above the negative x-axis, right? So we're considering the angle formed by the velocity vector of particle A with respect to the positive x-axis, right? So 150 point degrees is actually 180 point degrees minus 30 point degrees. Then, of course, b sub x b prime, all right, is yet to be determined, right? Since the final velocity of particle B along the horizontal is not given, right? So when we simplify this, we come up with 2.0, that's understood to be meters per second, equals negative 2.6, and then plus Vx B prime. The value of cosine 150 point degrees, okay, is actually negative 0.50, which when multiplied by 3.0 meter per second, we get negative 2.6 meters per second, right? So our expression for Vx B prime, therefore, will be Vx B prime equals positive 4.6 meters per second. We just transpose negative 2.6 meters per second to the left side of the equation. Okay. And when we add 2.0 meter per second to 2.6 meters per second, that's how we got positive 4.6 meters per second. The positive sign simply means that the x component of the final speed of particle B just after the collision is or has a direction, right? The horizontal component of the final velocity of particle B is heading towards the positive x direction. So that is the meaning of the positive sign. We are emphasizing both the magnitude and the direction of b sub x b prime. Similarly, we do the same thing for the y components of the momenta of the two particles before and after collision. So we have this equation. 0 here represents the initial y component of the momentum of particle A. That's before the collision. While mb sub y, b represents the inertial y component of the momentum of particle B. So we equate that to the sum of m b sub y a prime, which represents the y component of the final momentum after the collision of particle A, and m b sub y b prime represents the y component of the final momentum just after the collision of particle B. So when we substitute the given data and considering the mass small m, we get 2.5 meters per second. So as is now, after canceling the mass m, 2.5 meters per second represents the initial velocity of particle B along the vertical or along the y-axis. So that's equal to uh, 3.0 meters per second times sine of the angle 150 point degrees, right? So this term represents the y component of the final velocity of particle A after the collision. Of course, v sub y b prime represents the unknown y component of the final velocity just after the collision of particle B. So this simplifies to 2.5 meters per second equals 1.5 meters per second plus b sub y b prime. All right? The value of the sine of the angle 150 point degrees is positive 0.50, which when multiplied by 3.0 meter per second, we get 1.5 meters per second. So isolating b sub y b prime, okay, by transposing 1.5 meter per second to the left side of the equation, all right, where we have 2.5 meter per second minus 1.5 meters per second, we get the expression for b sub y b prime. That is, b sub y b prime is equal to positive 1.0 meters per second. Again, b sub y b prime, or the y component of the final velocity just after the collision of particle B, okay, is directed towards the positive y direction. Computing the final velocity of particle B just after the collision, that is b sub b prime, we use the Pythagorean formula. That is, b sub b prime equals the square root of the square of 1.0 meters per second, which actually represents the y component of the final velocity of particle B, right? Just after the collision, plus the square of 4.6 meters per second, which represents the x component of the final velocity of um, particle B, okay, just after the collision. So when we do our math, we get the value or the magnitude of the velocity of particle B, okay, just after the collision, equal to 4.7 meters per second in two significant figures. So what is the direction of this velocity vector? So as emphasized in this sketch, okay, we have the vector arrow representing the magnitude of b sub b prime. Notice that it makes an angle theta, right, with respect to the positive x-axis. So to be able to describe the direction of the final velocity of particle B just after the collision, we need to find the angle theta. So we just use the inverse of the tangent quantity 1.0 meters per second divided by 4.6 meters per second. So with the help of your scientific calculator, we find that the angle theta is equal to 12 degrees, and that is above the positive x-axis. So our final answer, therefore, the velocity of particle B just after the collision has a magnitude of 4.7 meters per second, and the angle of deflection is equal to 12 degrees above the positive x-axis, right? As shown in this sketch. So, we are done. Okay. Let me say mabuhay. Till the next episode. MashaAllah. Thank you very much for your indulgence. Please don't forget to subscribe to my YouTube channel